to run you through this, but this is my assignment for patch for interactive systems design. Excuse the motor noise if you can hear that. This patch is basically split into a few different key sections. We've got our particle generators, which are thanks to gem. As you can see, they work backwards, so this is actually like your input and this is your output. But once you get it, you get it. There's a low frequency, mid frequency, and high frequency. In here we have some sort of clipping. This takes the audio frequency data and splits it up into our different sections. It does this by a few different. This is a decibel gate, so no sound over 40 decibels is heard. This spigot then moves into a few little Moses gates. These are so anything below 130 comes out of the left terminal, and anything above 130 goes out the right. And then by stacking those two gates, you can get distinct low, medium, and high values. And then I've clipped those and done a bit of maths to make sure they're packed into 100, so they can be used for scale. Over here we have like our routed input data, and this comes from the ADC. It goes through Sigmund, which is picking up the three main sinusoidal waves and collecting that data. The main one we use is the first one that sends out the key frequency data, but the other ones I've combined and medianed for a kind of color output at some point. Wasn't included in the final thing. Here we have the sphere that sits in the center. It has some color adjustments. It's scale based on volume. It's rotation based on the pitch, the first pitch that we send out from the original Sigmund wave. Up here we've got like this kind of declare lib gem. This is a part of every single gem project. It just declares that the package is part of the project. And I have this nice little audio switch, which makes it nice and easy to demonstrate how the system kind of functions. You've got your main bit of data coming out from here, and then as these are changing and being inputted, it sends it mostly over here and then out to each individual section. It's pretty self-explanatory once you understand that it's just piecemeal, like each part has its distinct function. And then we've got the actual patch here. As you can see, it's pretty chaotic, but it's tracking my voice as I'm talking now through this microphone, which I thought is a pretty good demonstration of its function as a project. I like how you can rotate based on pitch, and you can kind of input any instrument or any sound or any song, and it'll adjust based on the different particle waves. We've got 3 distinct rings, each picking up our high, lows, and mids, and then our circle here, which is changing based on volume and then also rotating on pitch. So I go ooh, and as you can see, it rotates. It's a pretty cool project. Happy to go more in depth if required. Thanks.